We are discussing chapter 7 estimation. So last time we had two groups. So we discussed is how can we get the confidence interval for the mean difference, right? So let me go to the homework. When you get into the Cengage, yep, it's number 17. It's number 17 is the homework tonight. So let me get into the homework number 17. It has only 3 questions, right? And when I go to the number 1, yeah, there's a 2 sigmas, sigma 1, sigma 2. They are the indicator. They're using the z-score, the sigma, right? It's a I made a table, right? It's 1 sigma z-score, 2 sigmas the z-score, right? Today we are going to using the 2 S's, and we use the t-score with the 1s, and today 2 S's, yeah, t-score again. And the last one, proportion, z-score. Next Monday, the proportion difference is another z-score, right? So now the sigmas, the indicator, is using the z-score. And when I go to the number 2, number 2, then here is the sigma 1, sigma 2, again using the z-score. And number 3 is the z-score again. Yeah, sigma 1 and sigma 2. That is the indicator. So I want to try number 3. Do you have any other question? I want to pick one for the review, the confidence interval. So my choice is number 3, but if you have any other choice. Okay, I want to try this one. In part A, what distribution? Because we knew sigma 1, 2, 1, 2. So we have to use the standard normal distribution, the z-score, right? So the first one is the good choice, using the z standard normal distribution because we knew the sigmas. Then now let me copy and paste. It's onto the paint. Yep, here. In this homework, we have to use the formula x1 bar minus x2 bar. Yep, it's definitely we have to use the z-score, square root of sigma 1 square over n1 plus sigma 2 square over n2. Then let me plug all statistics into the formula. X1 bar is a 64.8 minus 2 bar 71.8, and I need a z-score from the confidence level. To remember, we can take the z-score from the t-table. Yeah, going to the t-table, 99% at the bottom there is a z-score. You can see the z-score 2.576. I gave you before 2.575, but the z-table gives us it's better one, 2.576. So let me take the z-score from the t-table, 2.576. Then sigma 1. 9.05 square over how many sample size? Wow, 9,680. And the second sigma is 11.64 square divided by 25,457. I set up it's everything. You know, we need more practice and more practice because it is long calculation. So you need the practice using your calculators as well, right? Yeah. So please is trying to get the answer. Then now let me take the mean difference. It's a 64.8 minus 71.8. the mean difference will be -7. Always the difference can be negative, right? It can be negative, positive, yeah, because that is the mean difference. And let me take the critical value. Let me take the multiplications later because it is a long calculation. Let me take only the inside of the square root. So 9.05 square divided by 9,680. And take the sum 11.64 square over 25.45, 7. Inside, there is the 0.01378. And now, just a second. And now, let me take the E, the margin of error. The E. Now then, 2.576 times square root of 0.01378. Then the E will be 0.3024. Then now let me take the smaller one to the bigger one. So it's a -7 minus 0.3024. The lower limit is a -7.3024. And let me take the sum. -6.6976. It is 99% confidence interval for the unknown population mean difference. Both of them is negative. What do you mean? The interval estimation for the difference, negative. Second one is bigger. The second one is bigger than the first one. The second one is bigger than the first one, right? It's absolutely, yeah. So we have a negative and negative. Let me check the answers. Let me go back to the homework tonight. And it must be with the 2 decimal places. So it's a -7.302, -6.70. When I take the rounding, it must be yes. Yes. Okay. Yeah. So I can interpret. I am 99% confident. Unknown population mean difference. It must be inside of the confidence interval, right? So that will be the interpretation of the it's a confidence interval, and the interval is a negative. So the second one is bigger than the first. So simply I just review the last one using the formula. It's a formula of this, right? With the sigmas and the z-score. Any question? That was the last topic. Yeah, it's comparing the two population means. It's make the confidence interval for the mean difference. When I go back to the homework, see, already I posted the homework number 18. It's a today's one, but the Friday, we don't have a class Friday, so it will be due next Monday. And already I reopened 14, 15, 16, and extend the due date 17 until Friday, next Friday, noon. Do you know what we have on noon Friday? Test, yeah, the third exam, yes. So when I check the second exam, it's already we finished chapter 6. So the third exam will be cover only chapter 7. I think, yeah, the chapter 7 has a 6. The 6 topics, the 6 kinds of the confidence intervals. But I expect It is easier than second. The second exam was too hard, right? Yeah. But I expect this exam will be easier than second exam because every single topic is a confidence exam. One sample, two samples, sigma, the z-score, S using the t-score, proportion, another z-score, right? Yeah. So, for example, if you got 90 in the first exam, yeah, it was too easy. And the second exam was too hard, 60, for example. And now, yeah, you do better, it's 80, right? And we are going to have one more exam. It will be the final exam. So in the final exam, you will get 140 because the final exam will be out of 200 points. It's a cumulative out of 200 final. Then how much will be the half of it? 70. So the worst score will be 70. Do you remember that, right? And additionally, I can add homework scores and the quiz scores. The total scores will be 100, another 100, 100, 200, right? And 100 and 100. Total 700. Totally. Then simply I divide it by 7 to get the average. I will give you the letter grade based on the average. Any question? Before a student asked me if the final exam will be worse. I mean, for example, 90. It's only 90 out of 200, right? How much will be half of it? 45. Do I have to change 60 to 45? No. Yeah. I just take the sum. Divide by 7. Yeah. Only when you will get better score than the worst one, right? Then I will replace it, right? The reason why I suggest this policy because it's some students is missed. Yeah, that is the grading policy for them. Yeah, who missed exam, right? But even I apply is any students who got the worse score than the final exam, then still, yeah, I will replace it, right? So do you understand the grading policy, right? So if you have any other question about the grading, yeah, please ask me. And also, I open it's all homeworks, yeah. And that the reason why I reopen now because if you missed or if you, yeah, I think most of you got already good scores in the homeworks. Yeah, you got is over 90. Yeah, you don't have to make them again. But if you miss or very lower scores, right, then you can make them up in this weekend. So maybe this week I will give you another summary. It's another summary homework, chapter 7. Yeah, the summary, right? Then you can prepare another your summary, and you can print out my summary. You can bring my summary, and you have to bring the Z table and T table. You must bring the Z table, T table, right? Yeah. And if you need more space to summarize, yeah, you can print out a new Z table, T table, one-sided. Yeah, it's up to you. So you can bring all of them, and we are going to take the third exam. Yeah. And the next week, next Monday maybe, I will post the review homeworks again. So already you got good scores, then please do the homework number 18 due next Monday. And next Monday, I will post the review homeworks, the bigger one, yeah, from chapter 7. So already you got good scores, then you just try the review homeworks when you are preparing the exam. Question? Yes.
Can you review how to get a Z-score from a confidence interval? Like, let's say you get confidence interval 85. Can you review how to do that?
What case? You wanna review one sample?
How do you get the Z-score for like a confidence?
Oh, last time, yeah, that's a good question. Okay, I see. Do you have any other question for the exam? It's clear. We are going to review. Yeah, we are going to finish chapter 7 on next month. Monday is no class this Friday, and next Wednesday we are going to review, right? And then we are going to take the exam on the Friday. Let me go to the T table. Last time I told you even we can take the Z-score from the T table. You remember?
Yeah.
Can I put them? No. Okay, here's the better. See? At the bottom, there are Z-scores, right? So if you have 80% confidence level, the Z-score will be 1.282. And already we knew 90%, the Z-score was 1.645. 95%, 99%.
What if it's one that is midpoint?
I will try. Which one do you want to try? Give me pick one of them. What? 87. That is a good example, but I don't know. What would be the Z-score.
Like in between one.
Oh, the between 85 and 9. Oh, okay. Let me try. It's 87. Oh, very picky.
Then we can use that table anymore.
Yeah, the case is 87% confidence interval. I mean the confidence level. We have to take the Z-score from the Z table because the T table does not have the 87%. But the idea was from the Z is mean equals 0 and plug 87% in the middle. Oh my God. 87% in the middle, then the left one, right one together. 100 minus 87. I have a 13%. 13%, right? Then divided by 2 because we need only the left one. Then I have a 6.5%. 6.5% will be 0.065. So I can say the left end, there is a 0.065. So we have to look for the probability 0.065 in the Z table, right? So let me open chapter 6. Yeah, chapter 6. Yeah, please look at your Z table. Yeah, here's a Z table. Here. How much? 0.065. 0.065. 0.065 and 5. 0.0643. What I'm looking for? 0.065. 0.065 is must be in the middle. Right? What will be the Z-score? 1.5, 1 and 2. We took the average. We took the average between 1.5 and 1, 1.5 and 2. So simply I can say is 1.5, 1 and 5. You understand? Right? Yeah. Because of that, we got the 2.575 for 99%. But how much was exactly from the T table? 99%, 2.576, right? Yeah. But from the Z table, we cannot look for, I'm sorry, here, we cannot look for exact probability 0.065. So we have to take the two Z-scores here and take the average. Good? Right? Again? Yes, yes, take the average. Sum up, divide by 2. I want to try another one, 80%. 80%, 10%. Where is the 10%? 0.1. Oh, it's this. Okay. I want to try one more. 80%. Then I have to look for 10% is 0.1. 0.1, 0.1. Where is the 0.1? 0.1 is must be here, right? Then I can expect the z-score must be 1.285. What is the z-score from the T table? 80%. From the T table, 80%. I expected the z-score must be 1.285. But how much is the z-score from the T table? 80%? 1.282. I told you, yeah. It is. It is. So either way, we can take the z-score. But T table has only 9 kinds of the confidence levels. The others, you must take the z-score from the Z table, right? Any other question? Okay, then let me go to the today's topic, unknown. Yes. Today's topic is another confidence interval for the mean difference again. But today, we don't know how much is the sigmas. I told you, it's many times I told you, yes, yeah, we are going to use the 2 essays, and we are going to using the t-score. That's it. It's almost the same. It's almost the same. So we are going to take the t-score, not the z-score, from the t table. So please look at this example. Yeah, here's an example. Confidence interval. Unknown. Let me see. Studying brain wave. Okay. Understanding people's behaviors. Yeah, as they sleep. Yeah, it's the brain wave in hertz. The number of. You understand what this for? Yeah, the brain wave. Yeah, I can understand. Yeah, but anyway. So now, how many students? We recruit 29 college students. Totally 29. And we divide into 2 groups. 15 and 14. Yeah, split 15, 14. The first group, 15 people, given the half liter of red wine. Yeah. Can you do it? You will be the second group. The second group, what? The 14, no alcohol. Yeah, yeah. So over 21, first group is under 21, second group. Yeah. Then they give them is a quarter liter of the red wine before they are going to sleep, and they measure the weight. I don't know, inherit something. So here is 15 with alcohol, and the sample mean is 19.65. Can you copy the statistics, because I need the statistics on the next page. So please copy the sample size 15 and the sample mean 19.65 and the standard deviation 1.86. And the second group is no alcohol, is 14, and the sample mean is a 6.59, and the next one will be S. Yeah, please copy that. I need the statistics to make the confidence interval for the mean difference. Did you copy? Okay. So now let me come here. We had the two samples, number 1 and number 2. Can you give me the mean, number 1? What was the average?
19.6.
And how about the second one?
6.5.
Thank you. And S's? The sample standard deviation, first one, please.
1.86.
Second one?
1.91.
Thank you. And the sample size was 15 and 14. Good. Let me make the 90% confidence interval for the mean difference. Yeah, let me copy the formula. X1 bar minus X2 bar. We are going to use the t-score because we don't know the sigmas. And S1 square over N1 plus S2 square over N2. Then now let me plug the statistics into the formula. 19.65 minus 6.59. Let me take the t-score later, right? Yep, it's a times 1.86 square over 15 and 1.91 square over 14. Okay, then now the problem is, what is the t-score, right? Before, when we pick a t-score, we needed confidence level. Do you remember the confidence level? How much was it? You couldn't remember? It was, let me see.
2.57.
It was 90%. Confidence level, the confidence level is 0.9 in the middle column, right? It's a 0.9. And now we need the degree of freedom. Just a second, degree of freedom. Before, we got only one N, one sample size. Who was the degree of freedom? N minus 1. Yeah, N minus 1 was the degree of freedom. But now we have two N's, 15 and 14. What does it mean? We have two degree of freedom. 14 from 15, 13 from 14, right? So now we have two samples, two sample size, two degree of freedoms, 14, 13. Any idea? Say again? Add up, then divide by 2, take the average. I'm sorry, no. No, we need only, yeah, that is a good one, but we need only one t-score, not average.
We don't have 2 t-scores.
No. Oh, that is a good try. Take the two t-scores, from 14, 13, 90%, and take the another average of the t-score. I like it, but no. Yes, what?
Would we use the tail area stuff up here?
That would be in chapter 8.
Oh.
Not yet. Yeah, good try, but yeah. The idea is very simple. Take a smaller one. Okay?
Take a small.
Okay. 14, 13. 13 will be the degree of freedom. Simply we just take one. What? Smaller one. 13. So why don't you go to the 90%, 0.90, and 13, smaller one. How much will be the t-score? Anybody who has a T table today? 1.771. Yes, it will be 1.771. We take the smaller one. Okay, then now let me take the difference. Let me take the mean difference. 19.65, 19.65, 6.59. The mean difference will be 13.06. Let me take the multiplication with the critical value, the t-score. Let me take the inside of the square root first. 1.86 over 15, and take the sum 1.91 square over 14. Then it will be 0.4912. Then let me take the E, the margin of error. E is a 1.771 times square root of 0.4912. Then I have a 1.2412. Then now, let me take the lower limit to upper limit. 13.06 minus 1.2412 is a 11.8188. And let me take the sum, will be 14.3012. It is what? 90%. It is the 90% confidence interval for the mean difference. When? We don't know the signals using the t-score. What was the critical value? Smaller one. We take two critical values. We take two degree of freedoms and take the smaller one. Yeah, so that will be the degree of freedom for the critical value t-score. Yeah, it's almost the same, but you have to be careful. It's to take the t-score, right? Yeah.
Not the same even when there's like a drastic difference between the two sample sizes, like say one was 40 something and one was 3.
We are going to have another exam in the quiz. In the quiz, we have a same sample size. I can show you. This is the quiz number 18 today. 29 and 29.
But if in this situation where we took the smaller one, if we had two different sample sizes, one being 40 and one being 3, do you still take the smaller sample
Yes,
size? Okay.
yes. 40 and 3, then 39 and 2. 2, always smaller one. The smaller degree of freedom will be the degree of freedom to get the t-score. Yes. But in this case, the same thing, the 28 and 28, absolutely 28 will be the degree of freedom.
So the sample size should never be that.
Never should what?
Sometimes,
Sometimes, it is not the only application in statistics. We have lots more statistical applications. So when we have that kind of example, 40, only 3, right? Yeah, we have to take care of the outliers and usually in that case, we have to apply another statistical application. Today I have enough time, so I wanna introduce you something, right? For statistics, right? Let me ask you, how do you feel today for statistics? The statistics course. Do you remember your feeling at the beginning of the semester? The very first day of the semester? How did you feel? Then, right? I cannot remember your face on finally I'm here taking statistics, right? Yeah. So comparing your field in before and today, how do you feel? Better. Thank you. Better. Yes. Hopefully. Right? Yeah. So, before I told you, statistics not easy, but what did I say? Not too hard. Agree? Now? Yeah. Thank you. Thank you. And thank you for following me, right? Because, in this course, it's not only in UAFS, it's any college, we have to finish up to chapter 8, right? But at the beginning of the semester, we had some snow days, yeah, a couple of snow days. So yeah, a little bit delayed. So I ran so fast. So thank you for following me. So it's almost done. Yeah, we have only one more chapter 8, one more topic, chapter 7, 8. Today, I want to introduce to you the minor program in statistics, right? Yeah, fortunately, we don't have a major in statistics, right? But we have a minor program in statistics. Let me ask you another one. Did I ask you what is a good job? Did I? Think about that. What is a good job? How do you think? What is?
Something I can enjoy doing for the rest of my life.
Oh, enjoy the job in your life. Oh, that is a good one. How can you enjoy it?
Maybe if I feel like I'm doing some kind of good thing.
Okay. What do you want to say?
Well, a good job could also be like something that you can make a living off of. Like, if you can't live off of what you're being paid, it's not really a good job.
Payment. It is most important, I think. Yeah. Somebody give me more money, I will enjoy my life. Yes, yeah. So higher payment, very important, right? And additionally, I need less work. More money, less work. I think that is the best job. Do you agree? I think I have a good job. You know why? Anybody who visited my office this semester? Many of you, thank you. Many of you emailed me. Yes, I think that is enough. But did you know where is my office? See, you paid to me a lot. Less work, right? Yeah, what a good job. Do you know why I have a good job? I think I major in statistics. Bachelor degree in statistics, master degree in statistics, PhD in statistics. It is the truth. I promise, I guarantee, statistics will give you more money, less work, right? So think about the minor program in statistics. Already you have another minor. Yeah, you don't have to take another minor in statistics. But if you didn't take any minor yet, but you have to take a minor in your major, in your program, then please think about the minor program in statistics. It gives you more money, less work. It is true, right? See, what a good thing is, everybody hates statistics. I knew it. But what is another fact? Everywhere, they need the statistics. So if you feel a little bit better in statistics, right? Is you don't hate statistics, but it's not love, but it's fine. Then think about that. It is a good chance. Even it's not even major, but minor in statistics. Absolutely, you will have a good job. You will have a better job in any field, right? So think about that. I'm taking care of the STEM minor program. Yeah. Additionally, one more faculty member. Yeah. She's much nicer than me. Yeah. We are taking care of the minor program in statistics, and it's actually the minor program needs 18 credit hours. Already you are taking 3 credit hours. Already, it's a 15 credit hours more. It's a 5 is advanced. Yeah. The 5 advanced courses, we can go slower. I told you we have to finish up 8 chapters, right? So I ran so fast, but it's advanced topics in statistics that we can go slow. I promise. It's more interesting, it's more funny, and slow, right? So if you are interested in the minor program in statistics, then please ask me. Okay? Yeah. Okay, let's do the quiz number 18. Yeah, here it is. Please make the 95% confidence. Oops, sorry. 95% confidence interval between two samples.
Wait, what, for 19?
Yeah, it is a quiz number 19. Yes. I'm sorry, 18. Is it, what did I say?
18.
It is 18.
Yes.
Yeah, it is 18. Did I say 19?
Yeah.
Sorry, 18. The formula must be x1 bar minus x2 bar. And you have to take t-score from the t-table. And s1 square over n1 plus s2 square over n2. And when I plug statistics into the formula, it must be 19 point is 99 minus is 20.48. Please give me the t-score later. Then square root of 2.78 square over 29 and 3.00 square over 29. Confidence level 95%. How many degree of freedom? 28. Thank you. Anybody who find the t-score?
1.701.
I got 2.048.
What did you say? 2.048.
048.
I wasn't looking at the 95.
Okay, 95. Yeah. 2.048. Then let me take the mean difference. No class this Friday. Have a nice weekend. If you miss any homework, please make them up this weekend. And see you on Monday. Oh, we have a good one. I love it. Have a nice weekend. It tastes good. How was that?
It's not good.
I was interesting.
He said, "Oh, come on."
You ever had like strawberry muffins?
No, I didn't try.
It's pretty similar to that.
Oh, really?
Sounds like-
Oh. I like Dr. Pepper, but always I'm drinking the regular.
How many people are taking on that?
Before pandemic,
Mhm.
I had more than 10 students every semester, but now I have 4 class. It's low, it's getting low. Yeah, that is the reason why I'm recruiting students.
See, I'm already taking.
Yeah, I think it's many students hate statistics, but but it is a truth, it is a fact. They need a statistics. Yeah.
Probably.
I think it is.
Hey, aren't we all in Brandley's class together?
Yeah.
Why don't we go after Brandley's class?
I have. I have.
Take a walk.
Okay.
No, no.
Just saying, I didn't know that anyway.
We're gonna be eating.
Before Brandley's class?
I work from 5 to 11. I could probably. I don't know, it's on time before, but you're back down your feet. It doesn't represent your. You said your thing.
Thank you. Thank you. Have a nice weekend.
Oh, my bad, Jesus.